Hello guys, welcome to Makaut Smashers and also welcome to our video on human-computer interaction or HCI. In this series, we will explore how humans and computers communicate and interact, shaping the technology we use every day. We will delve into the key principles like usability and user experience and examine the methodologies such as user-centered design and prototyping. We will also look at various interaction paradigms from graphical interfaces to voice and gestural controls. Plus, we will discuss advanced topics like accessibility, ethical consideration, and the future of HCI. So, join us as we uncover the fascinating world of HCI and its impact on our digital lives. So, at first, we need to learn about the introduction to human-computer interface. At first, HCI is a multidisciplinary field focused on the study, design, and implementation of interactive computing systems for human use. It involves understanding how people interact with computers and designing the technologies that let humans interact with computers in novel ways. HCI is critical in the design and development of technology because it ensures that systems are designed with the user in mind, enhancing the usability, accessibility, and the overall user satisfaction. By prioritizing user needs and behaviors, human-computer interactions aims to create more efficient, effective, and enjoyable user experiences, ultimately leading to more successful and widely adopted technologies. Okay, so the brief history of HCI. The history of HCI dates back to the early days of computing in the 1960s and 1970s, when the concept of user-centered design began to emerge. Early HCI research was driven by the need to make computers more accessible and usable for non-expert users. The field gained momentum in the 1980s with the advent of personal computers, which brought the need for user-friendly interfaces to the forefront. Pioneering work by researchers like Douglas Engelbart, who invented the computer mouse, and institutions such as Xerox PARC, which developed the graphical user interface GUI, laid the foundation for modern HCI. Over the decades, HCI evolved to encompass a wide range of technologies and applications, from desktop software to mobile devices and immersive environments like virtual and augmented reality. Now it is time to discuss about the key components of HCI. The key components of HCI include the users, computers, and the interaction between them. Users are the individuals who interact with the system, and they can range from novices to experts, each with different needs, preferences, and limitations. Understanding the user's goals, tasks, and the context of use is a fundamental to HCI. Computers, or the technology being interacted with, include not only traditional desktop and laptops but also mobile devices, wearables, smart home devices, and more. The design of these technologies must consider various aspects such as screen size, input methods, and processing capabilities to ensure a seamless user experience. Finally, the interaction refers to the ways in which users and computers communicate. This can include the direct manipulation of graphical elements, voice commands, touch gestures, and even more advanced interfaces like brain-computer interaction. Effective interaction design ensures that these communications are intuitive, responsive, and aligned with the user's expectations and capabilities. Principles and goals of HCI. At first, usability. It is a core principle of HCI that refers to the ease with which users can learn to operate, prepare inputs for, and interpret outputs of a system. It encompasses three main components: efficiency, effectiveness, and satisfaction. Efficiency refers to the speed and resourcefulness with which users can complete their task. A system with high efficiency allows users to accomplish their goals with minimal time and effort. Effectiveness. Effectiveness is the accuracy and completeness with which users achieve their intended goals. A highly effective system ensures that users can successfully perform their task without errors. Satisfaction measures the user's comfort and positive attitudes towards the system. A satisfaction system is enjoyable to use and meets or exceeds user expectations. Examples of good usability include the intuitive mobile apps like Instagram, where user can easily navigate and interact with features without extensive instructions. Conversely, an example of bad usability is a complex enterprise software system with a cluttered interface and poor navigation, leading to user frustration and frequent errors. So now, user experience. User experience or UX refers to a person's emotion and attitudes, behavior about using a particular product, system or service. While usability focuses on the functionality and ease of use of a system, UX encompasses a broader range of factors including the user's overall satisfaction, engagement and emotional response. UX aims to create the product that provide the meaningful and relevant experiences to users beyond just being easy to use. Factors influencing UX include emotions, satisfaction, engagement. Emotions play a crucial role in UX as they affect how users feel about the product. Positive emotions can enhance user satisfaction and loyalty, while negative emotions can lead to dissatisfaction and abandonment. So satisfaction in UX goes beyond just ease of use. It includes the overall enjoyment and fulfillment that users derive from using the product. High satisfaction indicates that the product meets the user's needs and expectation comprehensively. Engagement refers to how well the product captures the maintains the user's interest and involvement. A highly engaging product keeps users coming back and actively using its features. So in summary, while usability focuses on making systems functional and easy to use, UX takes a broader approach by considering the entire spectrum of user interactions, aiming to create products that are not only usable but also enjoyable and engaging and emotionally fulfilling. So now it is time to discuss about the HCI methodologies and techniques. So user-centered design, UCD. UCD is a design philosophy and process that places the user at the center of the design and development processes. It aims to create the system that are tailored to the needs, preferences and limitation of the end users. The UCD process typically involves several stages. At first, research. This stage involves the understanding the users, their needs, the behavior and the context in which they will use the system. Techniques include user interviews, surveys and observations, and ethnographic studies. Design. Based on the research finding, designers create initial design concepts, wireframes and prototypes. This stage focuses on creating the solutions that address the user's needs effectively. Testing. Prototypes are tested with real users to gather the feedback. These stages involve usability testing, where users interact with the prototypes and designers observe and collect data on their experiences and challenges. Implementation. The final design is developed and implemented into a functional product. These stages include the iterative cycle of testing and refining the product based on the user's feedback until the desired usability and the user experience goals are achieved. So the benefits of UCD include the increased user satisfaction, improved the usability and reduce the development cost due to early detection of issues and higher adoption rates of the final product. Prototyping. Prototyping is an essential technique in HCI for visualizing and testing the design ideas before full-scale development. There are two main types of prototypes, like low fidelity prototype and high fidelity prototype. It means low fidelity prototype, these are simple and inexpensive models, often made with paper sketches or basic digital mockups. They are used to quickly explore the ideas and get initial user feedback. Low fidelity prototypes focus on layout and conceptual design rather than the detailed aesthetics or functionality. High fidelity prototypes are more detailed and interactive models that closely resemble the final product in terms of appearance and functionality. High fidelity prototypes are often created using tools like Adobe XD, Sketch, Figma and InVision. So they are used for more in-depth user testing and to refine the design details before implementation. So prototyping tools and techniques help designers to iterate quickly and more multiple design options and gather the user feedback to ensure the design aligns with user needs. So the user testing. User testing is a critical methodology in HCI for evaluating the usability and effectiveness of a system. Some common methods include like usability testing. It involves observing the users as they interact with a prototype or final product to identify the usability issues. Participants are typically given a specific task to complete while researchers note any problem encountered. A/B testing. It compares the two versions of a design, means version A and version B of a software, okay, to determine which performs better in terms of user engagement, conversion rates and other metrics. This method is often used in web and app design to optimize the interfaces. Also, the YouTube also use the A/B testing when a video is published on YouTube. Okay, surveys. Collect the quantitative and qualitative data from users about their experience, preferences and satisfaction. Surveys can be used to gather the feedback on specific features or the overall user experience. The importance of feedback and iteration in user testing cannot be overstated. Continuous feedback from real user helps to identify the issues and the areas for improvement. It ensures the final product meets the user needs and expectation. Iterative testing and refinement lead to the more polished, user-friendly and successful product. So now it is time to discuss about the interaction paradigms. Graphical user interfaces. GUI are visual interfaces that allow users to interact with digital systems through graphical elements. These elements include the windows, icons, menus, pointers, okay. So windows means the rectangular area on the screen that display the content and can be resized, minimized or closed. Icons, a small graphical representation of programs, files or functions that users can click to execute the command. Menus, list of options or command that users can select to perform actions. Menus can be drop down and context based or pop up. Pointers, on screen symbols such as mouse cursor that indicate the position for user interaction. Design principles for GUI include the consistency, feedback, simplicity, visibility and affordance. Voice user interfaces. So VUI allows users to interact with systems through spoken commands. Examples of VUI include the digital assistants like Siri, Alexa and Google Assistants. These interfaces are increasingly integrated into smartphones, smart speaker and various IoT devices. Okay, so design consideration for VUI include the clarity and natural language processing. It ensures the system can accurately understand and process the NLP. Clear speech recognition is crucial for effective interaction. Feedback and confirmation, context awareness, error handling. So these are the design consideration for VUI. So gestural and tangible interfaces. Gestural and tangible interfaces enable user to interact with the system through physical movements and touch, often used in touch screens and immersive environments like virtual and augmented reality. Examples like touch screens, like found in smartphone, tablets and interactive kiosks, allowing users to interact through tapping, sweeping, pinching gestures. VR and AR, immersive environments where users interact with virtual objects using gestures, hand movements and specialized controllers. Examples include the VR gaming systems like Oculus Rift and AR applications like Microsoft HoloLens. Okay. So design principle for gesture and tangible interfaces including the intuitive gesture, immediate feedback, consistency, affordance, ergonomics. Okay. So by understanding and applying this interaction paradigm, designers can create more effective, engaging and user-friendly systems that cater to a wide range of user preferences and contexts. So it is time to discuss about some advanced topic in HCI like accessibility. Designing for accessibility is crucial to ensure that all users, including those with disabilities, can be effectively use and benefit from technology. Accessibility aims to remove the barriers that might prevent users with physical, cognitive and sensory impairments from interacting with digital systems. The importance of designing for all users include the inclusivity, legal compliances, improve the usability for all. Guidelines and best practices for accessibility are outlined in the Web Content Accessibility Guidelines like WCAG. The key WCAG principles include the preservable. Information on user interface component must be presented in ways that user can perceive, such as providing text alternative for non-text content and ensuring the content is adaptable to different devices. Operable. User interface components and navigation must be operable by all users, including those using assistive technologies like screen readers or voice control. Understandable. Information and the operation of the user's interface must be understandable, which include making text readable and predictable and providing the input instances. Robust. Content must be robust enough to reliably interpreted by a wide variety of user agents, including the assistive technologies. Adaptive and intelligent interfaces. Adaptive and intelligent interfaces leverage the artificial intelligence to provide the personalized and dynamic user experience. This interface adjusts based on user behavior, preferences, and contextual factors to enhance the usability and engagement. Examples of adaptive and intelligent interfaces include the personalized recommendation system like Netflix, Amazon, Spotify. Okay, adaptive learning systems like educational platform like Duolingo, Coursera employ AI to personalize learning experiences. These systems adapt the difficulty of content and to provide the targeted feedback based on the learner's performance and progress. So ethical consideration like privacy concern, ethical design principles like transparency, fairness, accountability, and user control. So by integrating these advanced topics into HCI practices, the designer can create more inclusive, adaptive, and ethically responsible technologies that better serve the diverse need for all users. So at the end of the video, thank you for joining us on this journey through human-computer interaction. We have covered the basics of HCI, explored its core principles, and looked at various interaction paradigms and advanced topics. We hope you now have a deeper understanding of how critical HCI is in designing user-friendly technology. Stay curious and keep exploring the evolving field of HCI. If you found this video helpful, please like, share, and subscribe for more content. Until next time, happy interacting.